Okay, so yesterday we have seen the data differences between database management system and data warehouse. Just give me a second. And we have seen the OLTP and OLAP differences between OLTP and OLAP, and we have seen the ODS, and we have seen the data mart. We have three types of data mart, independent data mart, dependent data mart, and hybrid data mart. And we have seen the differences between data warehouse and data mart. And we have seen the multidimensional data model. There we have facts and dimension. In dimension, we have seen SCD concept. SCD concept is very, very important. Like it's like slowly changing dimension, where we store the history and current data. And we have the types of SCD: type 0, type 1, type 2, type 3, 4, and 6. Okay, we'll continue with this types. This is something like practical. Whatever we have seen, everything is somewhat like theory. That concept you need to be understand and prepare it accordingly for the interviews. So this dimensions it will be helpful like in practical, in real time as well. This SCD, if you ask me facts and dimension, or it's will be helpful for ETL tester, not all the time. So for the interview, we know, right? So in whatever questions asking in the interview is different what we are working. So then absolutely, if you are preparing for the interview, then facts and dimensions are the very, very important questions for the ETL tester. And coming back to this SCD, this is very, very important. If they are asking us to implement SCD logics, most probably they will like 90% chances will be there to use SCD type 2, and then 4, sorry, 3 and 6. So we need to be make sure which type they are asking us to implement. So type 0 we have seen, it's called fixed method. We are whatever data we are extracting from the source, that will move to the target without any changes. So like that's called consider as a fixed method. But in type 1, we just override the old value by new value. Let's suppose any value is getting changed, that need to be like override. Okay, so let's suppose we have taken the consumer table. In consumer table, we have the consumer key, ID, mobile number, income, location, designation. So if we take 1001 person as a manager, if it is he is changing, he is getting promoted to senior manager, then that record, instead of creating a new additional record, it will just get override in that particular. So which column we are exporting the changes, everything will be mentioned in the mapping sheet or in a requirement document. So here we need to be check what are the records getting changed. All these records are correct, like correctly, like after run, it is getting populated or overwriting, or like it's not overwriting. All these validations we need to be do by using queries. We'll use the SQL queries to validate the data. We'll see the SQL concept right there. Will tell you which query and like will be useful to test the SCD concept. We are not going to SQL queries now, but now we are understanding the SCD concept. Just stop me, okay, if you have any questions.
Yes, yes, sure.
Okay, so next will be type 2. So type 2 we have seen we just creating the new additional record, or accommodate a historical aspect of data. It is nothing but any data getting changed. So that will be making a new record. That particular changes will be considered as an active, like inactive record. Older will become inactive, the new changes will become an active record. We'll be creating a new record to show that history and current data. So consider, we'll take the same example, consumer table. So there with the 1001 person, his current designation was manager. If he is getting promoted to senior manager, what will happen? 1001 person, previously he was manager, right? So that positions will be there. and he is now currently will be promoting to senior manager. So here this record will be considered as an older record, which is called as an inactive record, which is like history, right? So currently he is senior manager. Before he was manager. So like inactive, active, we are maintaining. So this is the first thing. Type 2, it's like creating a new additional record. Second thing, we are maintaining the start date, end date is current. You can't see the start date, end date in other types. We have the start date, end date in level sorry, type 6. In type 2, type 6 will have the started end date is current. Why we are focusing on this? Because as a tester we need to be validate this columns, because if the record new record is coming up, we need to be check whether that record is start date is getting populating correctly, and end date is getting populated correctly, like that. So that's why this three columns is very very important. So here coming back to this 1001 person manager, when he started his position, 13/3/2018, he was started his position as a manager. And end date always always it will be in a system's default date, like date format. You know, we have lots of data type. We have integer, we have float, and we have string, and we have care, varchar, varchar of 2. So we have lots of data type. Like coming to the date data type. So date data type, we have lots of formats in date data type, because like sometimes we have a DD, YYYY format, and sometimes we have YY, DD format, and sometimes we have DD colon and then YYY, and then hours, minutes, seconds. So like this is like general like few examples I have given, but apart from this we have lots of formats. So here why I'm telling this, we need to be make sure what is the start date, end date, date format. So we need to be asked the project team, we need to be asked the project business analyst what should be the data type. Okay, and we need to be make sure what is the end date or system's default date, so that every for SQL Server the end date will may vary. Maybe it will be in a 999 12 hyphen 31. So it end date will be system's default date, that it will vary from database to database. So this is one thing. End date always to be in a system's default date. System's default date will vary from database to database. The asset tester, we need to be make sure what is the system's default date for that particular database, and we need to be check whether we are exporting the correct format. Let's suppose for SQL Server database, we are exporting default date to be in a YYMMDD format, but you are exporting this you are seeing this data after loading the data to staging area for checking the transformation logic. We could see the date format to be in a DDMMYYY format. Okay, so this is an considered as an a bug, because this is the system's default date, but we supposed to be export this format, but here we are exporting 31, which is DDMMYYY format. So which is this is a bug which we need to be raised. So like if it is date data type, we should keep an extra eye. We should be check whether we are exporting this format, and we need to be make sure we are we are getting that particular format, and we need to be check this if it is sometimes they want us to save the nanoseconds as well. So we need to be make sure whether it is getting properly populated to target or not. So start date, it will be considered as when this record has been come to this particular database. I end date to be in a system's default date, and is current value, which is like flag. This is considered as a flag, and flag can be represented in Y or N, S or no, or it considered as zeros or one. Zeros will be no and considered as an inactive record, and one will be an active record, and it is current record, and that can be represented as an S or 1. So why will be keeping this? We know SCD, we are keeping the history data and current data. Like seeing this is current value, I can say this is the history record or this is a current record. Okay, so like coming back to this, here we could see 1001% will be getting promoted to senior manager. First point, it should create a new additional record. Okay, it has been created. So see, this is the older record, this is the new record. Okay, so previously he was manager and senior manager. Coming back to the start date, okay, so coming, let's suppose we'll take this 1001% is getting promoted today. What is that today? So 10, 12, 2023. Till what is happening? Okay, so here initially this could be in this format. Manager and senior manager. He was started at 13/3/2018. For the senior manager start date will be is getting promoted today. Just we have taken example is getting promoted today. So his senior manager positions will start from today, which is 10/12/2023. If you ask me what should be the end date for this inactive record and active record, this end date should be the start date minus 1, because he was 1001%, is currently senior manager. He was no more working as a manager. His position has been resigned on like 9/12/2023. Okay, so always we need to be make sure this end date should be minus ones of new record start date. Okay, this should be greater than this end date. We should not, it should not be more than start date. Okay, so end date should be less than of this new record start date. And for this new records end date, will be always like his position 1001% recently got promoted to senior manager, and we are not sure when his what is that resignation will get promoted again. So like that's why we have given end date to be in a system's default date, not only for that 1001%, for all the persons we are giving the end date as a system's default date. If it is getting promoted, then we this end date will get changed. See this 10, this manager position's end date has been changed 9/12/2023. Okay, and then for this, like now it should be a system's default date. And coming back to this is current value, this could be considered as an inactive record because this is working as a senior manager, not a manager. This record is older record. Right, so this will be inactive, which is considered as a 0 or n. Okay.
Okay. The end date of a previous record is automatically getting changed, right? The like developer have applied the logic for
Hmm.
that.
Hmm.
Okay. And we have to verify that. Got
Yes.
it.
So as a
And the
tester, hmm.
and for the new record, the end date is same like a previous record date or whether it's our system default date.
This one, this one, when this
No,
like
no, this one no.
uh,
End date of a
end date
new
is
record
for
is
new
what?
record, it will be a system's default date. Yes. So we
Okay,
are
okay.
not make sure, we are not sure, right? He is currently senior manager, and we are not sure when he will get promoted. If suppose he is getting promoted to senior manager, he done some good job and is getting promoted to senior manager to be a delivery manager. So what it will happen? So again, like it will create a new additional record saying that this could be a delivery manager. Okay, but here senior manager positions will get end up. Let's suppose we'll take 11, 12, 20, 20, 4 or 3, like we'll take 4. So this positions will be end up, and here it will be getting a new positions like 12, 12, 20, 24 is getting promoted with a new position. And this end date will be his currently delivery manager. So end date will be in a system's default date, and current like is current value to be in a yes or no. Sorry, it could be in a yes or one.
Yeah. Okay, good.
Okay, so this is one point. Again, if we are applying for the type 2, it will keep previous of one history. So here I have mentioned it will keep only one previous history. Here I have told 1001 person is manager, and then he become a senior manager and delivery manager. In the target sources, like sources have this data. In the target, it will keep only the recent history. See, he is delivery manager. What is recent history? His history will be
Senior
senior manager
manager.
and manager.
Yeah.
Huh. This manager will be not there. It will keep only the
Okay.
recent one previous history. It will keep only one previous history. Okay, that could be in a very
Okay.
latest history.
Got
Okay,
it.
this is another point in SCD type 2. So that's what SCD type 2, it will create a new additional record whenever the record is getting changed, and will maintain start date, end date is current. And if you check on the type 0 or type 1, start date, end date, we are not maintaining. And even for the is current value. So we need to be make sure we have the start date, end date, and this current value. After that, I have told you this, right? If it is getting like we are creating a new additional record, some changes is there, so it should be create a new additional record, and we are make sure that start date, end date, is current value is getting properly converted to proper format for both the records. So we need to be check for the new record, start date, end date is correct, and older record, start date, end date is correct. Okay,
Okay.
and
Yes.
we need to be make sure it should keep only one previous history. And like one time I have raised the bug regarding saying that like in map, in requirement or mapping sheet, it is mentioned S or N, but I will be receiving values as in a zeros or ones in that format. What is happening? Like data type is wrong, so that's why we are expecting the value to be we are getting the value to be in a zeros or ones. So we need to be raised even though the meaning is correct, but the way of written the data is client want to be yes or no, but it is given as in a zeros or one. So this is kind of bug, right? Even though the meaning is same, right? S should be in a one, his n to be in a zero. But we should, if the in the requirement they are mentioned it as an s or like y or n, the is current value, we should be maintain only two values, s or no. Okay, is y or n. Okay, if it is mentioned like that, we are expecting that all values to be y or n. If you are receiving zeros and ones, then it could be a problem. Why? Because the data type is getting changed. The developers might have given wrong data type, so we can export the values in zeros or ones. So this is we need to be make sure what should be we are what like which format we are exporting, and we are getting that same. And this is one thing. And for end date as well, sometimes what it will happen is for the older record, the end date should be get changed, right? So it should be get changed, and for the start date it should be end date plus ones for the new record. Sometimes that as well it not change, end date will not change. So that we need to be make sure. And start date, yeah, like in CD type 2, if it is mentioned as a type 2, we need to be take all this points, and we need to be validate all this like all this, like checking this a new record and start date and date is current, and one history. Okay, so all those things we need to be like validate. Okay,
Okay,
so
got it.
yeah, so if it is in a date format, not only for this SCD, in general, if you're having the mapping sheet and there you have the date format, and we need to be make sure and it need to be checked with the business analyst, saying that which format we are exporting the data to be in the target, and you should be communicate via Teams, or you can send a mail and get a confirmation. Sometimes what will happen is in mapping sheet they will be in general they just given the date format, because we can't keep like we can't guess ourselves and we are expert some values. We need to be asked them via sending in a mail and take that mail for the evidence, you know, right, what is evidence things and all,
Yeah, right.
so that it will be in future it could be in a safer side to us. Okay, so yeah, that's it from the type 2. Any queries here?
No, it's clear.
Okay, so next type will be type 3. In type 3, we'll be creating a new column to show previous value. So type 2 we have seen we'll be creating a new additional record. In type 3, we'll be creating a new column to show the previous value. Before you have created a new record, new row. Now we are creating a new column to show the previous value. Type 3 as well, we could save current data and history data. Okay, so we'll take same example, consumer table, and we have like column names like consumer key, user ID, mobile number, income, location, designations, and all. After when if any data is getting changed, we'll be maintaining their previous, we'll be maintaining the new columns. Like here you can see designations will like the client has been say, like requirement has been set, we are exporting the changes for the designation column. So let's suppose 1001 person, will take same example, current designation was manager, is getting promoted to senior manager. See here you can see the like value has been changed to senior manager, and at the same time will be like here you can see there is no new column, but after implementing the SCD type 3, we are exporting the new columns to be implemented to show the previous values. So previous designations, previous income, like this new columns has been created, and it is maintaining in a new like a new column with their older values. So 1001 person, current designation senior manager. If I check the previous value and it is a manager, that value should get populated to that column. Okay, so we are exporting the like designation changes. Income will also get changed. So to maintain the previous income, we'll be creating the new additional column and we'll be maintaining the new like values for that.
Yeah, it show all the records of previous data or only the data which is getting
Which is
updated.
getting updated. Which is getting updated. Yeah.
But here, see na, the record having
Here most of the
1003
things.
is there. The
Hmm.
allowance is same like 5,000 and the designation is also same. So is it visible or not?
1003.
Yeah.
Yeah, yeah. No, it should be null. If it is getting like change, then it will give us an older values here.
Okay.
Yeah, here this is created very long back, so that's why here you can see lots of errors. Okay.
Yeah.
Yeah, so for type 3, we'll be creating a new additional column to show the previous value. And like here, whatever value is getting changed, will be maintaining, we are not losing the data. So 1001%, worked as a manager. We are not losing that data. We just maintaining that data to be in a new column. Will be maintaining in a new column. In that, will be maintaining that value. Okay, so what is happening? We are storing the current data and previous data. Okay, so yeah, type 3 is clear.
Yeah, it's clear.
Okay, so coming back to type 4. So type 4, like it's very less used, and it's like we'll be keeping only the history data. So let's suppose here you can see type 1. In type 1, we just overwriting the old value by new value. So here there is no possibilities to store the history data. Right here, you could see only the current data. In the result, we could see only the current data. Like we are not storing the history data. But type 4, just opposite. We just storing the history data. About whatever changes, whatever record getting changes, only we are maintaining that history to be in a like will be maintaining that data to be in a separate. Okay, so like
Okay.
we'll be maintaining only the history here in like just opposite of type 1. Type 1 and type 4 will be just opposite. There will store his current, but here will store the history. Okay, and type 6 will be the combination of type 2 and type 3. So what is type 2? So we'll be creating a new additional record to store the previous value. Type 3 will be creating a new additional column. Right, so type 6 will be the combination of type 2 plus type 3. So that's what most of the times will use the type 2. If it is not using, we'll use type 6, because type 6 it will cover both the types, type 2 and type 3. Okay, so if we take the example with the same consumer table, we have the consumer key, ID, mobile number, income, location, and designation. So we'll take the same example, 1001%. We know type 2, we just maintaining the start date, end date, and this current value. And for the type 3, we'll be maintaining an like income. So previous income, previous designation. So 1001 person getting promoted to, will take same example, manager to senior manager. So we'll be creating a new additional record, and start date, end date is current will be more like vary accordingly.
Okay.
And this current value as well should get vary. And for this previous history will designation will be the manager, income will like previous income, whatever income here we have, that will go to the new column with new with that value. Okay, other values, if it is not only 1001, if it suppose we'll take 1004, so that as well currently delivery manager, and is promoted to an okay, so he's getting promoted to some COO positions. So then all the values will get updated accordingly. It should get updated properly. We need to be make sure whether it is getting like it is getting the value which is getting populated in the table in the database in the table, that value is properly like it is matching with the previous value. Sometimes still you can see as a manager here and previous as well manager. So if the code or some query has been not written correctly, then we can export this bugs. Okay, so
Okay.
yeah, the thing is we should and we have understand the concept. So concept wise, what is what we have understand, and how to test this. So each like each I have told you in type 2, we need to be make sure this new additional new rec. Sometimes it will be not create a new additional record. So that everything we need to be make sure where it is creating a new additional record, and we are maintaining this start date, end date, and with this proper format. And this I had told you this 1 or y. It asked us to y or n, but it is coming as in a zeros or 1. The values for this is current value will be coming as in a zeros and ones. So that as well another kind of bug. So like this, we need to be validate if they are asking us to like a requirement will be including this SCD. But very, very rare cases. That's what I've told you. If it is in a 10 projects, very few projects, 1 or 2 projects, they ask us to implement this SCD. So, and again, depends upon the requirement.
Okay.
Business, what they want. So it will vary. Okay, some people will even they will not use this SCD again. It will happen. So, but the thing is, whatever we are validating for the other projects, we need to be validate that everything like null check, duplicate check, special character check, and like record count and data check. Everything we need to be checked, and at the like additional to that, we need to be validate this SCD if they are asking us to implement this SCD concept. Okay, so this will be validated like after loading the data to an target.
Okay. Yeah, got it. Like, it is not compulsory to use all these types in each project, right?
No, no, no. Totally depends upon the requirement. If the requirement is asking to implement this SCD type 2 or type 3 or type 6, then you need to be check. I will share this sheet, okay? In the group, I can share. We need to be go to this and refer. If they are asking us to implement type 2, understand what is type 2, how it is getting the values getting populating, and then we need to be make sure wherever we need to be do our validations, we need to be check that accordingly.
Yeah.
Okay, so yeah, any queries in SCD?
No, it's clear.
Yeah, interview point of view as well, important question. SCD questions are important. So that's what they will ask. Type 0, type 1, can you explain first 3 type or last 3 type, like that. So the thing is, if they're asking, then we'll need to be tell what is type 0, it's an a fixed method, and what is type 1, all those. Okay, so yeah, good to go other topic, huh?
Yes.
Okay, so next concept is schema. So coming to the schema, like if you ask me whether we are using the schema, it's again depends upon the requirement. Not all the time will use the schema concept. Okay, and we have the data modeler team. You will be extracting the data, right? Before that, we have the data modeler team. That team, it's very, very important concept. How SCD is important to us, how few validation is important to us. So for them, data modeler team, they like important concept like schema concept is very, very important to them. Okay, so let's see what is schema. So schema is nothing but it will defines how data should be organized within a relational database. If I take a real-time example, consider a day-to-day example. Okay, so if we are building an apartment or like anything, if we take consider as we'll be building an apartment. So there we can't build an apartment directly, right? Before building an apartment, we should have the plan, right? We have the plan. This should be another this first floor should be this, and second floor this much of houses should needs to be built. All this we should plan, and then the build work will start on. So same likewise here, whenever they will be designing a database for any big database systems, they will start they will start the will design, will make a will make a design, either it could be in a star schema or snowflake schema or fat cancellation schema. So whenever dealing with the data warehouse, first thing will make the schemas. Based on the schemas, will start the implementation. Okay, so whenever we'll be dealing with any database for any big systems, we'll do the first thing is we'll make the schemas. Based on the schemas, we'll start the implementations. Okay, so that is like schema, like consider, we'll make a plan, we'll make the decisions whether we need to be implement the star or snowflake or path cancellations, and then we'll plan it how the data should be organized in the relational data within a relational database, and then move it for the different teams. So first we have a star schema, and we have snowflake and path cancellation. Snowflake will be used more. We will tell you why it should be used more. Okay, so got it. Any queries here? Schema.
No. Like,
Okay.
what is the purpose of this schema? Like, like the database into that we store our data. But in a schema, what exactly we are doing?
Will be organizing the data. Let's suppose your we have the data. We have like if you take the data, see this is considered as a kind of data, right? Consumer key, user ID, a mobile number. So consumer key, I could say integer value, and ID will be an integer, and others everything will be in a considered as an integer. Location will be in a like I consider as a string data type or character or varchar. That's what for ETL tester, the schema will be not useful all the time. Will This will be helpful for the data modeler team. That team will segregate will they will use they will use the some tools to segregate this facts and dimension data to be in a separately. So there they will implement this schema. So what type of schema needs to be implemented decided by that team. Okay, so
Okay.
here interview point of view, it's kind of very important question. Again, if you take the data warehouse concept, see if you're preparing for an interview, so their schema topic is important, SCD concept is important, and facts and dimension, and data warehouse data mart. So that's it, like data mart and OLTP, OLAP, and that data warehouse is obviously important. Like few concept will be there, maybe in a 10 to 15 concepts, not 15, maybe like below 10 concept will be there in data warehouse. So we know why we are learning this. So we will be dealing with the data. We should be make sure this concept, and whether we are implementing in real time or not, it depends upon the requirement and depends upon the how project structure has been created. So it will vary. Some people will use the schema, some people will not use the schema. They will just like extract the data and do the data, apply the logics, will validate the data and will move it to the target. Some people's not able, they are not required to extract the data. Development team will extract the data. So testers we just validate the data as per the mapping sheet, whether it is working as per the mapping sheet or not. That's it, and we'll load the data. So totally depends upon the project. The thing is we need to be understand how they are following it, and how what are the things they are expecting from us, and how the project structure. So anyway, if you designing, understanding the ETL design is very a big task. Like maybe it may be 1 to 3 projects. After that you will get to know how it is created and how they are like creating this design things and all. So maybe 1 or 2 projects you may face difficulties, but after that you will get to know all this concept. So why the staging areas kept, like in staging area, we'll use the retention. Retention isn't. We'll delete the data after some time. Staging, what is staging area? Like it's in a temporary place. Maybe we have not covered that topic. We'll see the topic. So staging area is a temporary place to store the data. I have some purpose. So that's why I'm just using that staging area to validate the data. Once I have validated, it should be get deleted automatically after maybe in a 7 days or 365 days. Everything will be mentioned in the mapping sheet. So how much days we need to be keep the data in staging area. So yeah, again, like why I'm telling is it sometimes all this concept will not be helpful to your project. So that's what like we need to be understand what they are experting and how they are following it, and what is our project flow, or the like what kind of tools they are using, like data, what kind of scheduling tool they are using, what kind of database tool they are using. If you're using the like if you're validating the data manually, then whether they are using the Excel or some other tool to validate the data in manual, or if it is using the automation. So we need to be check which programming language they are using. Sometimes they will use Selenium plus Python, or they will use only Python. So we need to be make sure which programming language they are using. And yeah, scheduling tool, TWS tool, and programming language. And then yeah, this and all common to, like we need to be make sure whenever we are like make working within a new projects. Okay, so yeah, coming back to the star schema, any general queries?
No.
Okay. So coming back to the star schema, so like it is the simplest data warehouse schema because it resembles like a star. So star schema we know, which is general meaning central node surrounded by the sub nodes. So like that here central will be have the fact table surrounded by the dimension table. So like in in star schema, every dimension tables is directly connected to the fact table. So see each dimension tables, that every dimension table should be connected to the fact table. It should be directly connect to the fact table. No dimension should be connect, like each dimension table should connect to the fact table. We'll take some example. We'll take a campus placement. Okay, so campus placement table we have. Okay, so in campus placement, this is one of the table. Okay, so consider there is some college, and they will be running in this program, campus placement program. So who will be the main persons? Definitely, students will be there to attend the campus placement, and company recruitment team will come up to hire the students. So other teams like who's that lecturers will be there. Other tables will be there. So this table I will consider as a fact table. And this fact table, like we or like dimension table could be in a students table and company table. So this I will consider as a student table. Okay, so this is considered as a student table. So in this, I have a student name, and which department that students belongs to. So every details will be maintaining in the student table. Coming back to this company table, so in the company table, like we have not only one company will come to that particular campus placement program. So we'll maintain in a separate database table like company name and which location that like that company is. And I will take this few, like we can take other columns as well. We have taken few columns. So here this fact table will be my campus placement table. Dimension tables to be in a student table and this company table. So here what is happening, this dimension table is connected, directly connected to the fact table. So this this company table and this dimension tables is directly connecting to the central fact table, this campus placement. If you take, maybe if you can create another, we have another tables saying that this college informations or teachers or lecturers informations will be maintaining their like lecturer's name and which subject they are taking, will be create another table and will be maintaining that table separately. So this table is connecting to this campus placement fact table. Okay, so this is one of the example for star schema. What I'm trying to say is it will directly connected to the fact table. Each dimension table should be connected to the central fact table. That will be called as a star schema. Central fact table will be there surrounded by the dimension tables. Okay, and each dimension table is joined to the fact table using primary key to foreign key. Okay, yeah, any queries here? Star schema?
Yeah, here, like as we discussed yesterday, the fact table contain only the numeric data, and the dim table contain only the
String values.
text data.
I will
So
maintain the student's ID and company ID. So each company, obviously, we have some ID. So here I will be maintaining only these two columns. Okay, but you will be, how you will get the student's ID, you will be get from the student's table, and how you will be get the company's ID, will be getting from the company's table.
okay.
Okay, so the thing is, star schema, central fact table will be there, surrounded by the dimension tables.
Yeah, like what is the purpose of this star schema? Like if we want any particular data, we can directly
It's
get
not,
it from the dim
uh,
table
it,
one.
it could be
Okay.
not helpful. Yeah, it could be not helpful for the ETL tester, but for the we have the separate data modeler team. Okay, that persons will use this much. They will be know what exactly to be in a fact value, what exactly to be in a dimension value. Sometimes in dimension as well, we have lots of sub topics, and that time we have, they will use that this concept very deeply. For us, maybe what is fine, and like in interview point of view, it's very important question. Yeah, you can go ahead, you will be asking something, right?
No, no.
Got it.
Yes, got it.
Okay, so yeah, a star schema, a central fact table surrounded by the dimension tables. And coming back to the snowflake schema, snowflake schema, it is more complex than star schema. Why? Because like there will be connect sub dimensions will be there. So snowflake schema dimension tables are connected to other dimension tables. So snowflake schema is a multidimensional data model that is extension of star schema, where dimension tables are broken down into sub-dimensions. So see, we have this fact table surrounded by the dimension tables that we know, that we have seen it in star schema itself. What make a difference in snowflake schema? Dimension can have the sub-dimension. So if you notice, see, central fact table will be there surrounded by the dimension table. This is fine. Here we have the dimension table that is surrounded, that is connected to the fact table. But this fact table, we have the subdimension. Okay, so dimension, we have the subdimension. So that is considered called as an snowflake schema. So fact tables, like it is multidimensional data model, extension of star schema. Here, if I don't use this dimension, this I can tell as a star schema. Why? Because we have central fact table surrounded by the dimension tables. So that's why it is called as an extension of star schema. And dimension tables are broken down into subdimension, then it will be considered as a snowflake schema. And like here, another important point is dimension tables can be have on a like single dimension, sorry, cannot be have on a subdimensions. So both the things is possible. This dimension we have this subdimension, fine, but this dimension we don't have any subdimension, this as well, it's fine. Okay, so both the things is fine. And another point is here. Yeah, we'll see one example for the snowflake schema. Here, we'll take the same example. So why I have taken the same example? We know is it like snowflake schema will be the extension of star schema, right? So here in this diagram, we'll create another table. We'll be creating the subdimensions. So keeping the student table, we have the student name. So in this name, I will be creating another table. This name I will be creating as another table called as a student name. In this name, I will be splitting the first name, middle name, and last name. So in this table, you are able to create another table, right? This is the dimension table. So we know student table is the dimension table, campus placement table is the fact table. So in the dimension, in the student dimension table, I was able to create a subdimension. How we can create the subdimension? Using the student name, I was creating the another table by splitting the first name, middle name, and last name. Okay, if you take the campus, sorry, company, see, company is the dimension table, right? So in this company table, will create the another, what is it, another sub table. Will take location. So we'll be maintaining the city and country. Like this, I will be having this columns. Okay, so and I will be not maintaining city, country to be in the company table. I will be creating the another table called as a location table, which is subdimension. Without this location main dimension, I can't create this subdimension. Okay, so we'll be maintaining the city, country. Let's suppose we'll take the Infosys. Infosys will be there in US. Infosys will be there in UK. Infosys will be there in India. So if you take the India, we have lots of state. So Infosys there in Karnataka, Bangalore. Infosys there in the Chennai in Tamil Nadu. So, like, we'll be maintaining all these informations, and I will be not dumping all this to be in a single company table. I will be creating a subdimension, and in the subdimension, I will be storing this information. So, how you have created the subdimension? There is one value is there, one column is there. Using that, you have been created the subdimension. Okay, so this diagram will be called as a snowflake schema. Central fact table, like we have campus placement and surrounded by the dimension tables. Subdimensions can be have the dimensions can be have the subdimensions. Like in this tables, we can create a subdimension, so we have created it. Okay, if you're not able to create it, then that as well, it's fine. Okay, so
Yeah.
that, mm, go ahead. Yeah.
Yeah. Like for the dimension, we can have the sub dimension, but for the fact, there is no sub fact table, right?
Correct. Fact should be only one.
Okay.
Dimension can be sub, but fact should not be sub. Okay, so both star as well, like central fact should be there, surrounded by the dimension. This dimension can't be directly connected to this dimensions. Okay, if it is connected, then that should be considered as a snowflake, because this dimension will be considered as a subdimension. This dimension subdimension to this dimension. If it is star schema, then central fact table will be there. Each dimension table should be surrounded to the central fact table. Okay, like that's called as a star schema, and a snowflake schema as well. Like it can be connected to the like sorry, it can be have the single dimensions, and like there is an if it is an having, we can create the another table in the dimensions. That dimensions will be, that table will be considered as a subdimension. So yeah. Another thing is the subdimension information. Who is giving this information? The dimension is giving the information. This dimension, if you want the dimension, that fact tables will, without this fact table, how this dimension table will come? Without the campus placement, how I will be interconnecting the company table, student table in one place? And that could be in a different table, that could be in a different table. I have some purpose, that purpose like will combine these tables, and then we'll make this diagrams, we'll make this design. Okay, so yeah, any queries? Hello.
Yeah.
Good to go over the topic.
Yes, yes. Good to.
Okay. Okay, so next will be fat cancellation schema, or we called as a galaxy schema. So this type of schema can be used as a collection of star schema and snowflake schema. So we have learned what is star schema. So we have learned what is snowflake. In the snowflake, we have this point extension of star schema. Coming to the fat cancellation schema, it's an extension of both star and snowflake schema. So like this points will be there. If you're preparing for the interview, this points is very, very, very important. Okay, so yeah, what is that? Collection of star and snowflake schema will be called as a fat cancellation. So here we have the multiple fact tables. So here we can have the multiple fact tables, but not the sub fact. Okay, so got that point, right? So you have like dimensions, you have many, right? So fact table as well, you can have many, and dimensions table as well, you can have many fact tables and dimension tables. And this can be the schema of Atkinson schema called as a galaxy schema. And disadvantage of the schema is like more complex design. See, like I have here one fact table, I have another fact table. Each fact table shares many dimension tables. So here this dimension table, sorry, this fact table, I have this dimension, and again I have this dimension, and if I take this dimension, I have the sub dimensions here and here, and fact tables again another fact table, and it will vary. So here if you see only this can be called as a star schema. So why? Because here central fact table will be there, surrounded by the dimension tables. If I combine, if I take till here, will be called as a snowflake schema. Why? Central fact table will be there, surrounded by the dimension tables. Dimensions can be have the subdimensions. So that's what the snowflake, right? So that's why path cancellation schema combination of both star and snowflake. Okay, so if I have another fact table, then it will comes under galaxy schema, which is path cancellation schema. Got it.
Yeah, I got these three types theoretically, but how practically we implement these?
That's what detailed test is very few, like few has been used. Will come to that. Yeah. In your case, in your project, if you are using, will come to that. Okay, this recording will won't disturb. Okay, will come to that.
Okay.
Okay, so coming back to this, we'll take. So another point is, so we have this points. All these points is very important. Another point is dimension table. So this fact, if you take this dimension, this particular dimension, this is like it is connecting two fact to both the fact tables, right? If I take this dimension table, it is connecting only to this fact table, but this dimension we can connect to the this fact table and this fact table. So there could be a possible dimension can be individual or mutually connected to both the fact tables. So this is another important point. Okay, so got it right. So dimension can be
Yes.
connected to like can be individual to one fact table or mutually connected to both the fact tables. Okay, so we'll see with the same example why again like it's in a combination of snowflake and star schema, right? So yeah, so we have another fact table which is like we'll take like we'll take real time example. So we have the campus placement and we have the higher education. So I will tell higher education to be another fact table. Why? There is a possibility students will go for the campus placement and few students will, this is the student table, right? So the student table is the dimension table. So there is a possibility campus placement, this campus placement to be an students can go for the campus placement or they will go for the higher education. Okay, so this is fact table. Higher educations is an fact table. So, like in this higher education table, I can create the sub like dimensions. Like I will create the dimensions like degree table. So in this degree, we have students. Let's suppose the students has been completed their bachelor degree. Okay, bachelor of engineering they have completed, so there is a possibility they can go for the campus placement or they will go for the higher education. So if I tell the higher educations, we have the sub dimensions like degree, like will take an MBA course or will go for like there could be a lots of option, even that students can go for the business as well. That everything is possible, but I have taken only two possibles. One is campus placement and a higher education. So if we have other related other data as well, we will make a design according to the data. I have only this much of data, I have made this design. Okay, so again, like we need to be check the data and we are creating the design accordingly. Okay, so this is fact table. So that's what I heard. Like lastly, I have told you dimension can be individual. So if I take the company table, it's an individual, individually connected to only one fact table, that is campus placement fact table. If I come back to the student table is mutually mutually connected to both the fact table. So it can be connected to campus placement or it will be connected to the higher education. So so here each dimension. So this design will be considered as an fat cancellation. Yeah, it's very bad, but yeah.
Yeah,
So
no worries. I can understand.
So till here, it's in a star schema. This yellow line will be in a star schema. Only fact tables and dimension tables, we don't have any subdimensions. And this green will be in a snowflake. Here we don't have the fact tables, only two here. this green line to be in a snowflake, and this entire diagram. So we'll take this entire diagram will be in a fat cancellation or galaxy schema. So that's what galaxy schema will be, the combination of both star schema and what is a snowflake schema. Okay, so yeah, any queries here? We'll come back to the later. We'll stop the recording and we'll come back.
No, it's good. I clear.
Okay. Okay, that's it from the schema topic. Okay, so like a schema is nothing but how data should be organized. Like it should be in a like snowflake format or in a what is that? Star schema format, that everything will be decided by the data modeler team, and like accordingly like if we are using the snowflake, then obviously we should understand or we should know what is snowflake and how this tables is like how the dimension and fact should be created, how that design should be made. Everything will be made in a separate team. Okay, for us interview point of view, like it's not in real time, it's not all time like all time we are using this facts and dimension and we'll use the schemas. So again depends upon the design, and if they are asking us to use this like implement this snowflake design, will follow the snowflake, then accordingly the respectively the validations might change. Otherwise, interview point of view, only it would be helpful for the ETL tester.
Okay.
Okay, so yeah, now that's it from the schema topic. And finally, normalization. So yeah, Unix will cover from the next week. Unix will see in next week. Normalization. So again, not an important topic for the ETL tester. But if I come to the data warehouse data concept, normalization is might be an important. So normalization is nothing but it's a database schema design technique by in which existing schema is modified to minimize redundancy and dependency of data. Let's suppose I have the database. Okay, in the database it's not if sometimes we'll take the address. Okay, in the address column I have my apartment number, I have my street name, and I have the pin code. Okay, in address it contains all this information. Then like will be from the source will be coming as in a separate column. We have the address column which contains all this information, but the source is ending as in a separate column, pin code to be in a separate column, street name to be in a separate column, apartment number to be in a separate column. So that time it's not useful, it's creating the unnecessary data. So we'll use the normalization technique, like first normal form, second normal form, third normal form, BCNF, fourth normal form, fifth normal form, like we'll implement this forms, and they will create at the end you will see only the few columns which is required for the database. Other columns, so first normal form will remove the duplicacy. Like that, we'll implement this forms, and at the end, will minimize the redundancy and dependency of the data. Okay, so yeah, it's like database schema design technique. Okay, so this is in a general topic. If you've been a CS background, this topic might be we have seen in the college days itself. But interview point of view, it's very rare questions in real time as well. It's a rare question.
Okay. Like where we are using this concept in our ETL testing.
No, normalizations we are not using.
Okay, thank
Again,
you.
interview as well. That's what in the initial itself I have told you. Interview as well, it's very rare. If you're learning the like see this week like previous week we have like seeing the data warehouse concept, right? Everything will be in a data warehouse concept. Here we are not
Mm.
gone to the any testing topic or like ETL. Somewhat it will be involved, but more focused on the data warehouse and data,
Yes.
and how we are we are not started our ETL testing, so we have covered only the data warehouse. So in that we have this topic.
Okay then. Yeah.
Okay, oh, it's 8:41. Okay, so that's it from the data warehouse. You have the syllabus. Let me check. Okay, so here we have this data warehouse. So in data warehouse we have this, what is database and database tool. Database tool will see the SQL and will see what are the tools and how we can implement that everything. And the data warehouse we have seen, and we have seen the OLTP, OLAP, and differences between OLTP and OLAP. And we have covered the data mart and types of data mart, like dependent data mart, independent data mart, and hybrid data mart. And differences between data warehouse and data mart we have covered, dimensional model and SCD, dimensions and their types, pairs and their types, and SCD and their types, and normalization. So that's it from the data warehouse concept. In interview point of view as well, if you refer the previous interview questions as well, most of the topics has been come under this if we take the data warehouse concept question.
Okay. Can you scroll down? The ETL concepts are there.
Hmm. You have
Yeah.
not started here.
Okay. Okay then. Yeah. Like, can we take this topic in the next week rather than these manual concepts?
That we can do. The thing is, uh, some people's okay. Maybe that will take it and with Tanvir. Okay, stop recording.
Okay.